Hello class, this is part 1 of section 10.4 on zero and negative exponents. For this section, we are going to go ahead and describe what it means to have a zero or a negative exponent. And first, we're going to go ahead and start with zero exponent. So in a power, we're going to have some base and the exponent is going to be 0. So what does that equal to? So in order to figure that out, we're going to go ahead and use a couple expressions. We're going to use the quotient of powers property to go ahead and give that a definition. So I have 5 cubed divided by 5 cubed. Using the quotient of powers property, that means that I keep the base and the two exponents need to be subtracted. So in this case, 3 minus 3. So when I rewrite this as a power, then this is 5 to the 0. Now, that's what we're trying to define. So in order to make a little bit more sense, let's go ahead and evaluate the first column. So 5 cubed, that means 5 times 5 times 5. So that is going to be 125. For the denominator, it's the same quantity, 125. So anytime I divide a number by itself, that's going to be 1. I have a negative base raised to the 4th power divided by negative 3 to the 4th power. So using the quotient of powers property, I keep the base, make sure that you keep it inside the parentheses, and then the exponents need to be subtracted, 4 minus 4. So rewriting this expression as a power, that means negative 3, 4 minus 4, 0. In the same way, evaluating that first column, that quotient, negative 3 times negative 3 is going to be 9, times negative 3, negative 27, times negative 3, that's going to be positive 81. The denominator is the same, so 81. So a number divided by itself simplifies to 1. And the last quotient over here, where we have powers that have a base that's a variable, we apply the same property. We keep the base and the two exponents need to be subtracted, so 6 minus 6. And rewriting that as a power becomes x to the 0. Now, anytime I divide a number by itself, it doesn't matter what it is, because in this case, I don't know what x is, but I have the same quantity for the numerator and the denominator, so that will simplify to 1 also. So all of these quotients simplify to 1. Anytime the power has an exponent of 0, then I will define that as being 1. Now this will only be true if a is different from 0, meaning it could be positive, negative, or it could be a variable. Meaning that if for some reason you ever encounter 0 to the 0, then we don't quite know what that means. Okay, so make sure that you keep that in mind. So this is going to be the rule. Anytime you see any base to the 0 exponent, then that's going to be equal to 1. Next, we're going to go ahead and determine the general rule for a negative exponent. So the power will look like this. We will have a base raised to some negative exponent. And once again, we want to define what that is. In order to do that, we're going to take a look at some patterns by looking at the powers of 2. We're going to start with 2 to the 3rd, or 2 cubed, and we're going to go down to 2 to the negative cube. So evaluating 2 cubed, that means 2 times 2 times 2, and that is going to be equal to 8. 2 squared, that means 2 times 2, so that is 4. 2 to the 1, that means 2 all by itself, and then 2 to the 0. Again, we define that to be 1, but let's take a look at another way to go ahead and also arrive at the same conclusion. So let's think about the following. So if we were to say, how do I go from 8 to 4? So I need to apply some operation so that when I apply that same operation to 4, I get a 2. If we think about division, 8 divided by 2, that's going to give me 4. And if I apply that again, 4 divided by 2, then I will get 2. So if I apply that to 2, then 2 divided by 2 is going to give me 1. Okay, so this would be another way to arrive at that same conclusion, that anytime I have a power whose exponent is 0, then it should be simplified to 1. Now, after this, we have the negative exponents. So let's go ahead and follow the same pattern, which is I'm going to go ahead and divide the previous number by 2. So if we take 1 and divide it by 2, we end up with 1/2. And if I keep applying that pattern, 1/2 divided by 2, then that's going to be equal to 1/4. And if I divide 1/4 by 2, then I will end up with 1/8. Now I'm going to go ahead and rewrite this in a different way. So we have 1 divided by 2, which I could rewrite as 1 over 2 to the 1. The 1/4, I could rewrite it as 1 over 4 is the same thing as 2 squared. 1 over 8, I could rewrite it as 1 over 8 is the same thing as 2 cubed. And the reason why I'm doing this is because I want you to notice the following pattern. Here we started with 2 to the negative 1. Here it became 1 over 2 to the 1. 2 to the negative squared became 1 over 2 squared. 2 to the negative cube became 1 over 2 cubed. So this is going to help us to arrive at the following conclusion, that anytime we have a power whose exponent is a negative number, then we are going to change it. We're going to rewrite it as a fraction. Now this we call the reciprocal. So anytime I have a power with a negative exponent, then I'll go ahead and write the reciprocal of that power. So I keep the same base, I keep the same exponent, but it will be the opposite. Okay, so instead of negative n, then it will simply be n. And this is going to be the rule that we will use to simplify or to evaluate powers that have negative exponents.